Hey, there you are. I guess I didn't chase you away from last time after we got into a little bit of detail on digestion. So, welcome you back, and we're glad you're here. Today, we're going to absorb some of those nutrients that we broke down last time in digestion. And this picture, we'll look at this picture again at the very end, but this picture just kind of shows you where in the intestinal system that nutrients are absorbed. You can see there are some duplicate places and things like that, but overall you can see that most of it's going to be absorbed in the small intestines, with a few things absorbed in the large intestines there. So we'll get into that, get a little bit of detail of how things are absorbed through the intestinal lining after we digest them. But the first thing I want to do, though, is because most of you at some point will be interviewing either to get into a professional school or into a job. And so I just wanted to prepare you ahead of time so that you can expect any kind of questions that are possible. So what I wanted to do is look at some of the most outrageous interview questions that have been presented to potential candidates, with the idea that you should expect anything because you have no clue what they're going to ask. Let me just go through a few just to get you mentally prepared for the time when you will interview. So let me look at number one. If you were to get rid of one state in the U.S., which would it be and why? This was asked by Forrester Research for a research associate candidate. Okay. How many cows are in Canada? Yeah. Ask at Google for a data quality evaluator. How many quarters would you need to reach the height of the Empire State Building? This was asked by JetBlue for a job as a pricing revenue management analyst. A penguin walks in through the door wearing a sombrero. What does he say and why is he here? This was asked by Clark Construction Group for an office engineer candidate. What songs best describes your work ethic? Asked by Dell for a sales candidate. What do you think about when you're alone in a car? This was asked by Gallup for an associate analyst position. I can't even say it. Can you say Peter Pepper picked a pickled pepper and cross-sell a washing machine at the same time? This was asked by MasterCard. If we came to your house for dinner, what would you prepare for us? This was asked by Trader Joe's. How would people communicate in a perfect world? This was asked by Novell. Estimate how many windows are in New York. This was asked by Bain and Company. What's your favorite song? Perform it for us now. Some of you are mute. This was asked by Living Social. And the last one that I know you would cringe if you got it, and you would be sweating bullets, because I've had some of you in BI 112. I remember your math skills, when we were working with the microscope and all that. So I'm pretty sure this question may temporarily have you thinking about where is the nearest exit that I can go, because this question was asked by Bank of America, and the question was, calculate the angle of two clock pointers when time is 11:50. Just saying. So be prepared for anything. You never know what kind of questions these people are going to ask. So I hope that makes you feel more comfortable about going into an interview. I'm just trying to help you here. I'm just, I'm on your side, so just saying, be prepared for anything. Anyway, here we go. Absorption. Basically, we digested all the nutrients last time. We got them down to the smallest things they can be to be absorbed through the plasma membrane and into the cell and eventually into the blood system or lymphatic system. So either of those is where we're trying to get those and get them across the membrane and eventually there. So that's what we're doing. We're going to go through and look at the histology or the structure of both the small and large intestines and talk about it and then look at how things are absorbed. So if we look at the anatomy of the small intestines, it's sometimes referred to as a carpet because what you have is finger-like projections that are sticking out into the lumen of the small intestines. The lumen is a cavity within the body if you haven't had A and P. And so where the food is, the tube, open part of the tube where the food is referred to as the lumen of the intestines. So these fingers are sticking out into the lumen basically to increase surface area. That's it. So you have more absorptive area. If you remember, the intestines are still going through peristalsis, and so not only are they moving the food 1 centimeter a minute, but as they contract and that they are helping to get the nutrients to make contact with the cell, because the nutrients have to make contact with the plasma membrane before they can be absorbed. And so there's several things along with the villi that are going to help do that, and one of those is the microvilli. And microvilli are like little hairs that stick up on top of each individual cell of a villi, because villi are just a series of cells, and they're absorptive cells. And so the microvilli are going to help capture those nutrients. So it'd be very similar to trying to walk through a blackberry bush or something, and you get caught in the blackberry bush. I don't think they're stickers, but or thorns, but anyway, you get stuck in there and you just can't get out. Well, the nutrients have to get stuck so they can make contact with the plasma membrane. And then we have goblet cells that are going to secrete mucus, because that's also going to help the nutrients kind of get stuck in there. So the purpose of the villi is to increase absorptive area, and then the cells of the villi are going to absorb the nutrients. So here you can see it looks like a carpet if you looked at it, and then we have each individual finger here that is sticking out to increase absorptive area. We've looked at this slide before, but I just want to show, here's the villi, but on each of these little cells, this would be one cell that basically has microvilli on top of it. But even on top of the microvilli, you basically have split hairs, right? So if you have split hairs, this is kind of what it looked like. But anyway, but they're even smaller hairs that help capture the nutrients. So as we're going through peristalsis, it'll make contact, and the nutrients will get stuck in there so they can make contact with the plasma membrane. So again, if you look at the villi, you see it's just a series of cells that go all the way around. They're absorptive cells or goblet cells, and so the nutrients are going to be absorbed into those cells. And what you notice is inside each of the villi we have a circulatory system. So we have the blood and either lacteal or lymphatic system, if you will, that is going to take those nutrients and take them some to the liver, and then the lacteal eventually dump into the blood system near the heart. So anyway, so that's the small intestines. The large intestine a little bit different. The large intestines really has no villi. It does have some microvilli on the cells because the large intestines aren't really made for absorbing nutrients. There are some nutrients absorbed there, vitamin K and biotin, but mostly water. And so you don't really need the extensions sticking out into the lumen. It's mainly for storage, but you do have the microvilli that will help slow down the water and make it so it can make contact, and some sodium, potassium salts, ions, those kinds of things will be absorbed there. So if we look at the system, you can see it's pretty flat there, but it has these crypts that go down through. My light just went out, but I'm going to leave it out. So if you can't see me, at least you can hear me. I don't know. Whatever. I'm too tired to get up and wave. Okay, it's Friday afternoon. I want to go home, and I'm not going to wave. That's just it. Anyway, okay, so this is a crypt, and you can see there's an absorptive cell, and it's got some microvilli here that are going to help just kind of slow things down and make sure we make contact. But so the difference is the small intestines, where basically 95 or more % of nutrients are absorbed, is built for capturing those nutrients. The large intestine really isn't. So that's one of the main differences. Once we get those nutrients absorbed, there's two systems they will go into. What we're going to find is water-soluble things will go into the bloodstream, and then fat-soluble things will go into the lymphatic system, or what is labeled here the lacteal system. So those are going to be the transport mechanisms. Once we get the nutrients absorbed, they're going to be then put into either one of these systems. If you remember from last time, we digested everything down into their smallest units, and what we found, the carbohydrates were monosaccharides. So we have glucose, we have fructose, we have galactose. We have the small and medium chains are going to be the 3-carbon glycerol with some fatty acids, amino acids for proteins, and then vitamins, B complex, and minerals would be ions. What I don't have on here is the, I don't know why I didn't put them on there, but anyway, the long chain triglycerides are going to be a monoglyceride and 2 fatty acids. So I apologize for not getting that on my slide, but just kind of write it in there, if you will. The long chain triglycerides will be a monoglyceride and 2 free fatty acids there. So what is the process? So we've learned the anatomy and looked at histology. So let's look at the process of water absorption. The small intestines, again, the microvilli are going to capture the nutrients. The absorptive cells are going to absorb those nutrients from the lumen. We are going to then put those into the villus capillaries, which is the blood system. Capillaries are the smallest blood vessel, they're like 1 cell thick, and so we pass right through. And then if we go into the blood system, we'll go through to the hepatic portal vein, and then those will be transferred to the intestines, and then the liver cells will absorb them. So the liver is kind of the central processing unit for nutrients, if you will, especially the water-soluble ones. They will eventually, and eventually then the fat-soluble ones, but we're talking specifically water-soluble that will be taken in this route. So if we look here, again, they're going to be absorbed. They're going to be absorbed into the blood system, not the lacteal, but the blood system, and basically be taken to the liver. But the way they're absorbed, I need you to remember that the types of transport, if you will, material transport. If you remember, we had simple diffusion, we had facilitated diffusion, active transport, that kind of thing. So glucose and galactose are going to be by active transport. So it's going to use ATP to get those nutrients into the cell. Fructose is going to be facilitated diffusion. So obviously all you need is a concentration gradient. If you remember that from BI 112, we need that concentration gradient for fructose. Amino acids are going to go, depending on what kind of what kind of amino acid they are, they're going to be a different transport, but essentially they're both going to be active transport. And so they're going to be going against the concentration gradient. As we mentioned, there are exceptions to the rules. As far as we're concerned in this class, I want you to know that remember that proteins are broken down into amino acids, but there are occasions where we'll have di and tripeptides that will be absorbed, but I don't want you to worry about that. And then the short chain fatty acids, they are basically able to work with water and lipids. So you notice that they're basically by simple diffusion, and all they need is their concentration gradient, because they can go right through the membrane without a protein. So if you remember active transport, we used a carrier protein. Facilitated diffusion, we used a channel protein. And then anything that is nonpolar lipid soluble, we can use simple diffusion. So that would be the water soluble ones that would go through, and then once they get into the cell, then they are basically going to go into the blood system. It's going to be a little bit different with the fat soluble ones. Okay. And then I just put this picture up to let you know that, you know, here's the intestines, and so they're going to be absorbed in the bloodstream and then take the hepatic portal system back up to the liver there. As far as fat-soluble nutrients, if you remember the long chain, it mentions 1 monoglyceride, 2 free fatty acids, and you can see that basically the outsides are going to be severed off and left the monoglyceride with the 2 free fatty acids. And these fatty acids are not going to be water-soluble like the short and medium chain. The other end products for fat-soluble would be cholesterol and any of the fat-soluble vitamins A, D, E, and K. Those are not going to be water soluble, so there's going to be a special mechanism to get them to the cells. The water soluble ones are pretty much absorbed in the duodenum. There is some that are absorbed in the jejunum, and then obviously the B12 is going to be absorbed in the ileum, as we kind of talked about a little bit with digestion. This in the small intestines, the fat-soluble ones, you know, most of them are going to be, as we mentioned last time, you have to, with the bile and, you know, having to sever off the outside fatty acids, all that, and peristalsis moving, pretty much the majority of fat-soluble things would be in the jejunum, but there is still some that could be absorbed in the duodenum. But in order to be, actually in order to get to the cells so they can make contact with the plasma membrane, there's a special structure that is produced, which is basically lecithin, which has cholesterol in it, and bile, which has cholesterol in it, are going to be emulsifiers. But the bile and lecithin are also going to be a covering to make what's called a mycel. And the lipids are basically going to be inside of this structure that is going to allow it to go through what we're going to refer to as the unstirred water barrier to the cells. So there tends to be a barrier. It's kind of like if we didn't have a bridge, then you could think of that unstirred water barrier as the Columbia River, you know, the bridge from Portland to Vancouver. You could kind of think of it that way, is that before bridges, we had to have a mechanism by which we could transport ourselves or our cars from Portland to Vancouver. And in some places, I don't know if they use these in Portland, but I would imagine to Vancouver would be a ferry. So you can kind of think of mycels as a ferry that carries the cars and stuff across to get to the other side. And so it's very similar in that we're going to have to transport these lipids through this water barrier across the Columbia River to the absorptive cells, because they're neutral, they're nonpolar, so they won't go right through the water barrier. And so this mycel is a transporter. Let me show you some pictures of that. So I've kind of drawn the unstirred water barrier here, and you notice, I mean, anything that's water soluble can get right through it, but what can't get through it is anything that's lipid soluble. So you formulate a mycel. Now inside the mycel, you are going to have cholesterol, you're going to have the fat-soluble vitamins, you're going to have the monoglyceride, you're going to have the 2 fatty acids, and I think I mentioned cholesterol. So you're going to have all of those inside of the mycel. Please remember that you are not going to have triglycerides because they have been digested down into monoglycerides and 2 free fatty acids. So all of that's going to be in the mycel. The mycel then is going to transfer those across this unstirred water barrier and get them to the cells. Once they reach the cell plasma membrane, basically the mycel is going to open up. It's kind of like, the ferry that would take you across the river would unlock the chain and open it up so you can drive your car off and go to Vancouver or the other way. So in this case, what's going to happen is the whole mycel is not going to be absorbed into the cell. What it's going to do is open up and allow the fat-soluble vitamins and the cholesterol and the monoglyceride and the fatty acids, because they are nonpolar. Remember, they can go right across by simple diffusion. All we need is a concentration gradient. So they would just go right across into the cell, and then we would have them absorbed. So anyway, so absorb the lipids from the mycel. Inside of the cell, we are going to reassemble the monoglycerides and the free fatty acids into a triglyceride. And then what's going to happen, once again, we can't just put fat right into the blood. The blood is mostly water. So as you will well know, I hope, is that if you pour oil or put fat into water, it's going to float. So you can't just put the triglyceride, you can't put the fat-soluble vitamins, you can't put the cholesterol right into the bloodstream because it will float. So you have to put it into a vehicle, and that vehicle is called a chylomicron. The chylomicron has a covering very similar to a plasma membrane in that it's phospholipid, but it's only one layer. You're not going to have a lipid bilayer. And so all the lipids, anything that's fat soluble and not water soluble, is going to be inside of that covering of the phospholipids. And then the mycel remnant, so the ferry is empty, and so now you're going to take it back, and actually the mycel doesn't go back and pick up anything else like a ferry does, so that's where our story ends about the ferry. But the mycel remnant is going to go back into the lumen of the intestines and work its way down, which is one... And if you remember, the remnant, the covering has cholesterol, has lecithin, cholesterol with the bile and stuff like that. So it can be reabsorbed, kind of broken down and reabsorbed later, which is one of the cholesterol piece of this mycel is one of the things that the soluble fibers would pick up and not allow to be reabsorbed. So that's what we were talking about, that the water-soluble fiber, the soluble fiber will pick up cholesterol, if you will, kind of make it attached to it from what we eat, but also what's produced by the liver, because bile is produced by the liver and all of that. So anyway, here's kind of a representation, again, kind of going back. Here's your mycel. It has everything in here, and it's going to go and let everything off, okay, and go in. But the mycel itself is not going to go and be absorbed into the intestinal cell. It's going to go back out into the lumen. Okay, and then this piece right here, what it shows is here's your monoglyceride, and you're going to reform it and make a triglyceride, and then form a chylomicron, and then that chylomicron is going to be put into the lymphatic system, not the blood system. And there's a reason for that, and it has nothing to do with its solubility, because the chylomicron could go right into the blood system as a transporter, because the heads of the phospholipids are going to be polar. But the problem is the size. Because if you look at an artist's rendition, it's pretty big. It's a pretty big structure. So it cannot go, it can't squeeze through the cells. Some things can squeeze right through the cells, but this can't squeeze in between the cells, so it has to go another direction to get, couldn't get through the cells of the blood system, the vessels. So it goes another direction, and that's the lacteal. Because they're going to be, the lacteals or the villi lymphatics are going to absorb the chylomicron. They're going to transport it to the subclavian vein, which is up here by the clavicle or the collarbone. And then it's going to be transported through the heart. So it goes a long ways until it gets to the liver. And then at the liver cells, you will go through like a phagocytosis. That will engulf the chylomicron and take it in to the system. But it will be a remnant at that point also, because as you go through the system, and we'll talk a little bit about that later when we get into lipoproteins, because the chylomicron is going to be considered a lipoprotein. We are going to see that as the chylomicron is transferred through the system, if cells need some lipids, they can take them from the chylomicron. So the chylomicron is actually going to get smaller and smaller before it actually gets to the liver. And so it's referred to as a chylomicron remnant, if you will. So again, here's the lacteal system, this yellow stuff here. And so the chylomicron is going to come from the cell into the lacteal system there in the villi. I just showing you here that this blood vessel is pretty tight, so it has a lot of, so to get into the blood vessel, you have to go through a lot of tissues to get in there. So the chylomicron is just too big to get in between the cells and things. But when you get to A and P, you'll find that the lacteal system basically has flaps on it. The lacteal system is mainly it's kind of a waste depot where excess fluids would get back into the bloodstream. And because if when your nutrients get to your cells, not only are you going to transfer nutrients from your blood through the blood vessel walls and so forth to the cells, but also some water is going to go there too. And so you have to get rid of any excess water or you're going to get swelling. So one of the ways you get rid of excess water is that it can go through the flap and get into the lymphatic system. And that is where the chylomicron can get through. It can go through the opening of this flap because the flaps will allow something bigger structure to get through. So again, it's not that the chylomicron can't go right into the bloodstream. It could and work fine. It's just too big. And so it's going to go into the lacteal system. And what I'm showing you is then the lacteal system will, come up here and eventually go to the lymphatic duct here. And at the lymphatic duct is where you have this subclavian vein. So it's going to dump in here. So the thoracic duct here and the right lymphatic duct are going to dump into subclavian vein, which is basically going to go into the superior vena cava and go into the heart. And then eventually we'll get back into the system. So absorbing and transporting fats, it takes a little bit more complicated than water soluble, but eventually it will get to the liver. And we'll talk more about that later. Vitamin K is a fat-soluble vitamin, but we actually make it in our intestines. But also, being fat-soluble, it has to be part of the mycel. in the small intestines, and I just listed here just so you have an idea of where the vitamin K might come from. Green beans. There's not a lot of vitamin K in food, and so, but I mean, if you eat the right foods and stuff, it's kind of like nutrient dense and vitamin K kind of foods, but you can get it. But a lot of it is made in the intestines and absorbed in the large intestines, absorbed there in the colon. Which is why, again, one of the reasons that if you're on chronic antibiotics, they might have you eating yogurt to replace the bacteria in your intestines, because you could, vitamin K is important for blood clotting. I guess I should have mentioned that. So it gets into your system and is part of the the blood clotting system, and so if you are lacking in vitamin K, you become a bleeder possibly. So it'd make your blood too thin, or you couldn't clot your blood. So if you're on chronic antibiotics, which basically if it's broad spectrum, it would destroy the bacteria in your colon. And if you're not eating the right foods, or usually if you're on antibiotics, you're not eating very well anyway. So if you're not eating the right foods or not enough food, then a lot of vitamin K come from your intestines. But if you're on an antibiotic, it's going to kill the bacteria there. So a lot of times they might prescribe a prebiotic or something in yogurt or whatever, probiotic that would give you some bacteria to make that vitamin K with. All right. Salts, sodium salts, sodium chloride, sodium chloride and potassium chloride, broken down, but they're going to be absorbed in the large intestines also. And then water, obviously, about 80% of the water that gets, into your small intestines is going to be absorbed in the large intestines. And that's usable water. So that's why if you have diarrhea, you have to be very careful, because you can become dehydrated because your body's used to having that 80% be absorbed. So if you have diarrhea, then it's not. So it becomes a critical problem at some point. All right. Alcohol really doesn't have to be digested. So it's going to be absorbed very easily through the mouth, through the stomach, especially if you haven't, in the stomach, especially if you haven't eaten food, the information that I've gotten is you would absorb 20% of the alcohol if you on an empty stomach, so it would get right into the bloodstream, because alcohol is water soluble and fat soluble, so it goes right through the membrane by simple diffusion basically, and gets in there, and so anyway, it can get into your system very quick, so there's really no digestion or absorption problems with alcohol. So here's the slide we saw at the very beginning, and as you can see, I'm sorry about that thing coming up. I'm not sure what it is, but anyway, you can see that most of the water-soluble vitamins would be absorbed in the duodenum. A lot of them in the duodenum, but some of them can sneak into the jejunum there. B12, we mentioned, was in the ileum because it needs the intrinsic factor to fit to the receptor, but you can see there are some things that are absorbed there. And then the large intestine, you can see, doesn't really absorb a lot of things. There is vitamin K here and biotin, because they're made, actually I should have mentioned biotin is also made by bacteria to a certain extent there. And then mostly water, and then some salts and things like that. So I'm not expecting you to remember, obviously I'm not going to have you memorize this whole thing, but I would expect you to remember that water-soluble vitamins are basically absorbed in the small intestines, and mainly in the duodenum, and most, like we said, 95% of digestion happens in the duodenum, so that's where absorption is going to be. But some of the simple things like sugars and things like that are going to be absorbed there, and then the nutrients. So anyway,